We can now move on from the cartoon example to look at an example of a real ensemble forecast. We'll consider an actual prediction of the tropical Pacific sea surface temperature back in August 2010 from initial conditions in March 2010. It's a 6-month ahead forecast. And it was an important forecast because a strong La Nina developed in the tropical Pacific over the period and was a major factor contributing to severe drought in East Africa. But before we look at the forecasts, let's just recall that we call the collection of predictions from the model, all for the same time, in this case for August 2010, an ensemble. Each individual forecast is called an ensemble member, and the ensembles are carefully designed to capture the forecast uncertainty. So let's look at the tropical Pacific region and its temperatures at that time. Climatologists use the red shaded region in the inset map in the tropical Pacific to monitor the state of El Nino and La Nina. It's known as the Nino 3.4 region. The black line at the top shows the observed differences of the sea surface temperature in this region from September 2009 through to February 2010, just ahead of the forecast. And we'll be referring to sea surface temperature by its usual abbreviation SST. Remember, we're dealing with anomalies, that's differences from normal. So the black line shows positive SST anomalies, warmer than normal, and peaking at nearly 2 Celsius above normal in December 2009, which reflects the El Nino conditions that were present at the time of around the forecast was made. Observations with negative SST anomalies would appear below the 0 dotted line. Now, a forecast was started from initial conditions gathered from March, and the forecast ensemble was an ensemble forecast with 42 ensemble members. And here we see the ensemble members predicting forward for 6 months in these 42 orange lines. You can see that to begin with, the ensemble members are closely grouped together. They all predict similar SST anomalies. So the uncertainty is small at first, but as the forecast proceeds, the ensemble members spread out as the initial uncertainty grows. And at the end, there are large differences across the ensemble. A few ensemble members predict a near zero anomaly, and at the other end of the scale, a few predict an anomaly of around -2 Celsius, with the other members predicting a range of values in between. I think you'll agree this looks rather similar in principle to the ball spreading out at the bottom of the pin table in the cartoon example, and the processes at work, sensitivity to initial conditions, are similar. Of course, in this real case, uncertainties from model imperfections are also present. So this is an ensemble forecast, but how do we turn this into a probability forecast? Well, to do that, we need to go back to defining events, as we discussed earlier. And the events of interest in this case are the usual thresholds on SST anomalies used to define El Nino and La Nina events. That's a positive anomaly of more than 0.5 Celsius for El Nino, and a negative anomaly of less than -0.5 Celsius for La Nina. An anomaly in the range between these thresholds represents neutral conditions. So let's now proceed with a series of questions. From this ensemble forecast, estimate the probability of neutral conditions, the forecast probability of neutral conditions. That is neither a La Nina event nor an El Nino event by August. The tip here is to count the number of ensemble members that at the end of the forecast are in the neutral range. That is, they predict the SST anomaly will be greater than -0.5 Celsius and less than plus 0.5 Celsius. And I'll give you about 20 seconds. Five, 4, 3, 2, 1, time's up. So the answer is the forecast probability of neutral is about 20%. There are 8 members, you can count them, that fall in the neutral range, and there are 42 members in total. The estimated probability of an event is the proportion of members that predict that event. 8 divided by 42 is about 20%. So just to repeat that, the estimated probability of an event is the proportion of members that predict the event. And that's the same for when we are predicting the tercile rainfall events or other sorts of events. This is the main way the probabilities are calculated from ensemble systems. There are other ways involving some additional statistical manipulation, but this is the most common way. So let's have another question. What about the forecast probability of a La Nina event? Again, I'll give you 20 seconds. Five, 4, 3, 2, 1, time's up. The answer is 80%. 20% of ensemble members predict neutral. No ensemble members predict El Nino. So the predicted probability of a La Nina event is simply 100 minus 20, or 80%. About question 3. What was the observed condition in August? Was there a La Nina event? Was it neutral, or was there an El Nino event? Well, that's easy. The observations were well below the minus 0.5 Celsius threshold by August, and a La Nina event was well established. Finally, question 4, was the forecast right or wrong? We forecast an 80% chance of La Nina, and a La Nina event happened. Were we right? What if we had forecast only a 30% chance? What then? Right or wrong? Well, it's a tricky question, and we'll look at this in more detail next.